Day 829 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 1510, Stone Game 4. The difficulty level is hard, but don't worry because you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, hype, subscribe, comment, and share. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. Alice and Bob take turns playing a game with Alice starting first. Initially, there are stones in a pile. On each player's turn, that player makes a move consisting of removing any non-zero square number of stones in that pile. Also, if a player cannot make a move, he or she loses the game. Given a positive integer n, return true if and only if Alice wins the game. Otherwise, return false, assuming both players play optimally. Alright, y'all, so that may seem a little bit confusing at first, so let's go ahead and take a look at these examples just to make sure that we are doing this problem correctly. So, in example 1, our input n equals 1, the output is true. Explanation says Alice can remove one stone, winning the game because Bob doesn't have any stones. So in this case, there's only one stone. Alice goes first, so she can take that stone. We just want to return true if Alice wins and false otherwise. So since Alice goes first and there's only one stone, we return true because Alice wins. Now, just in case that didn't make sense, let's take a look at example 2. So in example 2, our input n equals 2, our output is false. Explanation says Alice can only remove one stone. After that, Bob removes the last stone, winning the game. So in this case, remember, on each player's turn that a player makes a move consisting of removing any non-zero square number of stones in the pile. So 1 is a square number, 2 is not a square number. So Alice can remove one stone, but she cannot remove two stones. So since she chooses to remove one stone, that leaves Bob with another chance to get the last stone, and whoever gets the last stone wins because the next player won't be able to make a move. And it says right here, if a player cannot make a move, he or she loses. So in this case, Bob wins because Alice gets the first stone, Bob gets the second stone, and then Alice is not able to make another move. So just in case that didn't make sense, let's take a look at example 3. So in example 3, n equals 4. The output is true. Explanation says n is already a perfect square. Alice can win with one move, removing 4 stones. So in this case, 4 is a square, perfect square. Alice can take them all because 2 times 2 is 4, which makes it a perfect square. So since it's a perfect square, Alice can take all of the stones and win the game on the first move. So boom, y'all. Now that we understand the question, let's get into the fun part, the actual solution. The solution is not that difficult at all. Now, the first thing we're going to do is we're going to create our dynamic programming array, which will represent whether the current player can guarantee a win when there are exactly I stones remaining. Initially, every position is assumed to be losing, but the dynamic programming array of 0 is going to remain false because there are no stones left. The current player cannot make a move and therefore loses. So to create that variable, we'll say var dp equals an array, open up the parentheses, repeating colon false comma count colon n plus 1. Boom. Now we're going to calculate whether each number of stones from 1 to n represents a winning or losing position. So we'll come underneath this and we'll say for I n 1 dot 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 n. We'll open up the brackets and we'll start checking perfect squares beginning with 1 square. So we'll declare a variable called j and we'll just set that equal to 1. Boom. Now a player can remove any non-zero square number of stones and continue while j if squared is not greater than the number of stones currently available. So we'll say while j times j is less than or equal to I, we'll open up the brackets and we'll remove j squared stones and look at the resulting game state. If dp of I minus j squared is false, the opponent would be placed into a losing position. Therefore, the current player can choose this move and guarantee a win. So we'll say if exclamation point dp square bracket I minus j times j will come outside of that. We'll open up the brackets. We'll say dp square bracket I come outside of that. Set that equal to true. Then we already found no winning move, so there's no need to check any additional square numbers. So we'll come underneath this and say break. And then we're going to try the next perfect square by coming underneath this all the way right here. Oh, sorry. First, we're going to come right here, and we're going to say j plus equals 1. And then we need to return whether the first player can guarantee his win by coming right here. And we're going to say return dp square bracket n, y'all. Boom, that should be all she wrote. Let's give it a run. Make sure it runs properly before we submit it. It's accepted, so let's go ahead and submit it. Make sure it's still accepted after we submit it. And look at that, y'all. 11 milliseconds beats 75% of users. That's what I'm talking about. That's what I like to see, y'all. So, with that being said, y'all, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.